This is the video for the extension lesson to 3.4, Factoring Expressions. In this video, you will learn how to use the distributive property to factor expressions. Writing numerical expression or algebraic expression as a product of factors is called factoring the expression. Remember, factors are what you multiply together to get a product. You can use the distributive property to factor expressions. I like to think of this as undoing the distributive property. So if you look at the number side here on the left, we have 3 times 7 plus 3 times 2. Our goal is to take a factor that you see in both expressions. In this case, on this side, we have 3 times 7 and 3 times 2. Well, each of them have a 3. So we're going to take that 3 and put it outside a set of parentheses. Once we do that, all we have left is the 7, the plus sign, and the 2. On the other side, I'm going to do the same thing. So what I have the same for factors in both terms is an A. So I'm going to put that outside a set of parentheses. And then what I have left is a B plus C. In example 1, we're going to factor 20 minus 12 using the greatest common factor. Our first job is to find the greatest common factor of 20 and 12. I still like to use factor trees. So the factor tree for 20, two factors of 20 are 4 and 5. 5 is prime, so I circle. Factor pair of 4, 2 and 2, so I circle both. So my prime factors of 20 are 2 times 2 times 5. Factor tree for 12, factor pairs are 4 and 3. 3 is prime, I'm going to circle. 2 and 2 for 4, circle both. Factors for 12 are 2 times 2 times 3. Then I'm going to circle the ones they have in common. So all I have are two sets of 2's in common, so 2 times 2 is 4. That's our GCF. Now what I do is I take that GCF and I put it outside a pair of parentheses. I bring down the operation that's already being used, which is the minus, and then I take that 4 and I'm going to divide each of those terms by the 4. 20 divided by 4 is 5. 12 divided by 4 is 3. This is my answer. This is the factorization using GCF. If I wanted to check it, all I would have to do is distribute. I'm going to redo what I did. So I would use my arrows. 4 times 5 is 20, minus 4 times 3 is 12. I should get the same thing up here. In order to answer the question in example 2, which expression is not equivalent to 16x plus 24, I still have to think about factoring the expression. So 3 of these are true and 1 is not true. In order for it to be true, the number outside the parentheses, this, 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 and this, if it's true, they're going to be factors of both 16 and 24. So I can start eliminating. Is 2 a factor of 16? Well, I'm going to say yes it is. Is it a factor of 24? Yes. How about 4? Factor of 16 and 24? Yes. 6, a factor of 16 and 24? It's a factor of 24, but not 16. How about 8? Is that a factor of 16 and 24? Yes, it is. So by process of elimination, I can probably say C. But let's double check. I can distribute each of these to see if I should actually get 16x plus 24. 2 times 8x, 16x plus 24. Yep, that still works. Distribute this. 4 times 4x and 4 times 6. 16x plus 24. Sure does. If I distribute this guy here, 6 times 3x, 18x 6 times 4 plus 24. That does not match. Here, I'm going to distribute the other way. It still works. 8 times 2x, 16x, 8 times 3, 24. That matches. Example 3. You receive a discount on each book you buy for your electronic reader. The original price of each book is X dollars. You buy 5 books for a total of 5x minus $15. Factor the expression. What can you conclude about the discount? Okay, so let's factor this expression first. I have 5x minus 15. I need to find the GCF of 5 and 15. Just looking at these, I can tell since my only factors of 5 are 1 and 5, and my factors of 15 are 1, 3, 5, and 15, I can tell that my GCF is 5. Therefore, I'm going to factor this using 5. So I stick that number outside the parentheses and put the minus sign straight down. If it's a plus, I put a plus there. If it's a minus, I put a minus there. Now I'm going to divide this GCF into both these numbers. But don't forget the x. The x just comes along for the ride. So 5 divided by 5 is 1, but keep in mind, if I have 1x, I don't actually need to write the 1 in front of it. 5 goes into 15 3 times. So 5 times the quantity x minus 3 is the factored expression. Now we need to answer the question, what can you conclude about the discount? Well, if I look back up in the story problem, it said the original price of each book is X dollars. Five, that's how many books I bought. What does that mean? Well, this 3 here, that tells me how many dollars they took off of each book that I bought. So that's my discount. That means I got $3 off per book.